I realized in the last video I didn't talk about why the integral test works. So I'm going to use 1 over n squared to demonstrate why the integral test works. And as a reminder, what the integral test says is that if the corresponding integral converges, then the series converges. So we did 1 over n squared up here as an example. So let's just jump into this here. You can see here I have an image of y equals 1 over x squared being graphed on Desmos. It's got this shape right here, and that's key to what we're going to talk about here. Notice I've drawn this, so I just drew this half of that. The other thing that I'm going to say is I'm going to use these x-axes ticks as units. This is 1, 2, 3, 4, 5. I'm going to leave the y-axis without ticks. I'm just drawing this for the shape. This would be squeezed down much tighter. You know, look at this. This would be, I think, 11 or something like that. So you can see it's almost on the curve there. So this is stretched vertically, a vertically stretched version of this graph here, and just the first quadrant of it. So remember, this integral converges. I think it might converge to 2 or a half or something like that. But this integral converges. So what I want to show you is that that integral converges. It means that this series also has to converge. So here's how we're going to do this. The series, sigma, oops, I'll go back to purple, sigma n equals 1 to infinity of 1 over n squared. That's going to be 1 over 1 plus 1 over 4 plus 1 over 9 plus 1 over 16 plus dot, dot, dot. So what I can do, if I want to add these out for forever, I can look at these values and how they show up on the graph of y equals 1 over x squared. And let me zoom out just a little bit here. I'm going to change colors. Ooh, I'll take that. That's fine. All right, so look, these values right here. If this is 1 over x squared, then 1 over 1 would be the height right here at x equals 1. It would this is the height of this graph, oops, at that spot. And then this would be 1/4, right? So you could see the scale. Like this would be 1/4, this would be 1. You can see it's like not linear, right? So I'm just going to get rid of those guys. Actually, maybe I'll leave them. No, I'm going to get rid of them. I don't want them there. All right, so, and then the 1/9 would be this height. And the 1/16 would be this height. And the next one would be this height. The next one would be this height, and so on. Now, what I can do is I know that this integral from, 1 to infinity of 1 over x squared is equal to a number. It converges. It is a number. I don't really care what it is in this scenario. But what that tells me is, all right, so that integral is actually 1. So that means that this purple area under y equals 1 over x squared from 1 out to infinity is exactly 1. So what I can show is that because that is a finite value, that these numbers here also have to be a finite value. And here's how. What I can do is take this little block right here. This, that was just going over to the right from this height right here. Remember that height was 1. This thing has an area equal to 1. And then I could say, all right, so that's an area equal to 1. So this is equal to, this summation is equal to 1 plus the rest of the areas, okay? And look, 1/4, that would be this one, 1 over 4. That area of that rectangle is 1/4. And then the area of this rectangle would be 1/9, the next term. And then this area would be 1 over 16. And then this one would be 1 over 25. And as I go out, these are all numbers, and they're the numbers that I'm adding. These will be the numbers in the sequence. So when I go out to, like some random spot here, right? This is just going to be a sub n for the n value that we are at. And the argument here is that the 1/4 plus the 1/9 plus the 1/16 plus the 1/25 plus all of the rest of these, they all add to something that is clearly less than this purple area. And remember, that purple area is exactly 1 as you go out to infinity. So my sigma from n equals 1 to infinity of 1 over n squared is going to be 1 plus a number where that number is less than the purple area, which is 1. So what does that tell me? That this summation from 1 to infinity of 1 over n squared has to be finite. Oops. Finite, which means that it converges. I'm not saying what it converges to, I'm just saying that it is finite. You may say, all right, cool, I get that, that's fine. But what about this part of the integral test? Well, imagine that this was not 1 over x squared, but for example, 1 over root x, which I know diverges. All I have to do for the proof is make the same argument, except for instead of going left, I go right for each spot. And then I don't have this extra 1 block. And then hopefully you can visualize that or see that. If I go to the right for each of these, then I can show that the summation, for example, 1 over root n, would be bigger than the integral of 1 over the integral from 1 to infinity of 1 over root x dx. And since the integral diverges, the summation, the series, would also diverge. So hopefully that makes some sense. If my second explanation didn't make some sense, try drawing it out, and I think it will click for you. And the next video is going to be on p-series.